Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, LadyAda, the engineer, and with me is Mr. LadyAda. We're here at the Adafruit factory in downtown Manhattan. We do all of our manufacturing and testing and kitting and coding and shipping, et cetera, et cetera, et cetera. But right now the factory is quiet because we're going to have 1 hour of Ask an Engineer.
That's
Ding!
right.
That's the show you're watching. So let's kick it off because we've got a lot. I see this show is massive in front of me.
It's a big show.
Let's kick it. What is up on tonight's show?
On tonight's show, the code is traffic, 10% off the Adafruit store, all the way up to 11:59 p.m. Eastern Time. Use the code and save $1 or $2. We'll talk about our Adafruit live series of shows, including Show and Tell. We host Show and Tell. There's a bunch of cool, amazing makers. Time travel. We'll look around the world. Makers, hackers, artists, and engineers have a special treat. We went out to a museum and saw some art. Chip shortage, everyone's favorite segment this week. Chip shortage, Texas Instruments. We need stuff from them. Maybe they'll send it to us. We've got some retro tech as well. This one's going to be a little different. You know, we got some stuff going on. We got a cool thing we're going to show you. From the mailbag, this week is a special from the mailbag because we have a song. Folks like the new song. And then we added the chip shortage song. And now we have a mailbag song. Help wanted, look at jobs board on Adafruit, jobs.adafruit.com, post your skills, or if you're a company and want to hire cool makers, post up the job there. We look at all these to make sure they're not weird or sketchy. We'll do some factory footage from Adafruit, the advanced manufacturing company made in New York City. Some cool 3D printing videos and more with Noam Pedro. We've got Eye on MPI this week, it's NXP. We've got new products, got a little bit top secret. We're going to answer your questions. We do that on Discord, adafruit.it/discord or discord.gg/Adafruit. Join all 34,000 of us. All that and more on, you guessed it, Ask an Engineer.
Amazing.
Yeah. Okay, so in addition to saving 10% off LadyAda, you can get free stuff. What do they get?
That's right, $99 or more, we get a free Permaproto half-sized breadboard. Perfect for taking your solderless breadboard projects and making them permanent on a lovely silkscreen board. $149 or more, you get a free STEM QT sensor breakout or controller. We have about a dozen different boards and sensors that we have as an assortment. If you make an account, we'll get you a different one each time because we know which one we've already sent you. And $199 or more, you get free UPS ground shipping in the continental United States.
That is destined to change because everything's expensive.
Yeah.
Next up, when you do use Adafruit.com, please consider making an account, verifying it, and putting two-factor authentication. That's good for security. It's also probably going to be the only way that you'll be able to get some products because there are a lot of automated tools and bots and people buying stuff and then reselling it because there's a global part shortage and more. So please, please, please do that. And like I said, use the code, get the free stuff, do the authentication. Everybody will be happy. We have a live series of shows, LadyAda, and we do live shows almost every day of the week. And we're back on Show and Tell this week.
Yes, we just did it.
Yeah. So
it was wonderful.
First up was Jay from DigiKey.
Jay.
And then Sherry stopped by during the Maker Music Fest. And then we had Jeff. We had Phil B, who showed an amazing retro Sony computer.
The Hitbit?
Yeah.
Yeah.
We have a black one at home.
Not as
and
cool
he has
as
a red
his.
one. So the red ones were only no, they're all cool. They're all fine.
Red's pretty cool.
As
though.
one as one Adafruit entity, we have like market share of these now.
That's right.
So
a significant number of Sony Hitbits are operational.
Every quarter, Sony says, how are the Hitbits doing out in the market? We sold this thing 30 years ago. How are they doing? They're like, this Adafruit company is getting them all.
Yeah.
So we have some retro hardware that you can check out. And then Noam Pedro showed off a cool project that they're working on. One is this headphone thing they were doing, and this lightning bolt. Scott came by with Scott's latest project, a kid. Scott's back from paternity leave, going to also take some time off again soon, but you could check out Scott and Kiddo on there, cute kid. And I was saying how cool it will be to be Scott's kid, because Scott teaches and shares quite a bit, and what a cool, fun adventure that's going to be for Kiddo and for Scott and
That's right.
family. So welcome aboard to this world, Kiddo. We've tried to not mess it up so much, but you might have to fix it. So we also had Liz with the laser harp.
And we had Matt Maker.
And we had Matt the Maker showing off the latest project. So that was show and tell. On Sundays, we do Desk of LadyAda. What was part one of this week's Desk of LadyAda, LadyAda?
Part one is I showed off some samples that I got. I got motorized pots. I got some ultra wideband modules. I am working on a tester for the NAU 7802, and I got some stretchy conductive rubber.
Okay. And then we do the Great Search, which is really handy because a lot of folks are like, where and how can I possibly find these parts on digikey.com? Sometimes they need substitution, sometimes they need other things. What did you do this week on the Great Search?
Okay, so this week, because I've been working on the NAU 7802 breakout, I was thinking, if there's other people, you can't get the chip right now because there's a part shortage, and the only parts I have are the ones that I ordered like a year ago. But if you want to do Wheatstone bridge type measurements, like 24-bit ADC inputs, like very precision, slow but precise ADC measurements, I found two options, I2C and SPI, for precision adjustable gain amplifiers that have 24-bit ADCs and have I2C or SPI out.
Okay. On Tuesdays, we do JP's product pick of the week, and this is a live show where the discount code's automatically applied. You don't need to do anything. And one of the things I might suggest to JP is, so we had a project where you can do a little alert when there's Raspberry Pis in stock. Maybe we could do one when it's product pick of the week time. I don't know. So here is this week's highlight.
It is the LiPo Charging BFF, Best Friend Forever add-on for the Cutie Pie. Take your BFF and you take a Cutie Pie and you just set them back to back like that. Now you can see this example here, I've got some header pins on there. This gives you a JST plug for adding a LiPo or lithium ion battery. It has a little on-off switch there that you can use to turn on and off the battery power to the board. This makes for really great wearable projects. The Cutie Pie M0 plugged right into the BFF, and I've soldered those with the castellated pads. Got this nice little NeoPixel demo running here. Battery power, can turn that on and off with the power switch, and we can also charge that right off of the USB. My best friend and yours forever, it is the LiPo Charging BFF add-on for Cutie Pie.
And then we have JP's Workshop, which is tomorrow. And every week on JP's Workshop, in case you missed it, we have a special section, CircuitPython Parsec, and we have that as a special feature that we do here on Ask an Engineer. So I'm going to play it.
For the CircuitPython Parsec today, I wanted to show you how simple it is to use a mouse cursor in CircuitPython, particularly on the PyGamer or PyBadge. This can be generalized for other boards, but it's really almost plug and play with these two boards to use the Adafruit cursor control library. So you can see here I have a PyGamer, and I'm going to move the joystick around, and you'll see I get this nice smooth cursor action. There's a little bit of streaking, I think, on the video playback, but in real life it's really smooth, really nice. And you can see here, this is probably slowing it down a little bit, but just so I can have some output that could be useful, I am printing in my serial output here the cursor position on X, Y. If I go ahead and resave that with that commented out, now it's probably going to run even a little smoother. You can also see here I'm doing things like click. When I click a button, I get a little update about clicking. And the way this is set up is really easy. First thing I'm going to do is import the cursor control and the cursor control cursor manager, set up the board, put the mouse cursor onto the display using display IO, and then during the main loop, all I do is cursor update. So internally, the library checks to see if it's a Pi gamer or a Pi badge, and it automatically hooks up the XY of the joystick or of the D-pad buttons to the XY of the mouse. Now you can do things like change the speed of it, change the size of it with additional controls, but the most basic usage of it is this really nice, easy cursor that you can then use to build other applications on top of. And we have some great examples of both this simple setup as well as clicking some buttons and having things change as you click the buttons. And so that is how simple it is to set up a cursor on a Pi gamer or a Pi badge inside of CircuitPython using the cursor control library. That is your CircuitPython parsec. Wow, wow, wow.
Okay, and as we mentioned before, probably this week, it'll still be Tim, Foamy Guy, who's been filling in for Scott Fridays at 2 p.m. Pacific. So tune in this week. There might be special guest Scott. Next week after this, there might be something. So Deep Dive will have other, I guess, passengers in the sub soon.
Yeah, it's a big submarine.
We all live in a purple submarine. Okay, time travel. Time travel does not have a theme song yet, but I'm working on it with Tom. I got some ideas. Probably something like Huey Lewis in the News. Back in time. That's the idea. A little bit of reminder. AdaBox was winter edition. It's spring. Waiting for stuff. Part shortage. Reminder, adabox.com. Sign up. We have a lot of people waiting. We don't charge until we ship. Thanks for your patience. Okay. Look, I got to do it. It's a public,
Look, I mean, it's fast forward time travel.
It's a public
Look,
service.
wait, people can't say we didn't tell them.
It's a public service announcement.
Okay, now it's time for art.
It's time for, so time travel. We got an email from someone, and they said, hey, do you want to come to my art opening in New York City? Because I'm coming in, and I use your stuff for my art. And I'm like, that sounds great. We'd love to go out and do something like that. So we're getting ready to go. And he said, by the way, I'm not going to go COVID, because everyone's getting COVID. But you should still go. And we're like, okay, we'll go. So first I'm going to show you a little bit of a preview. This is some of the art. It's made with NeoPixels and photography. And this is the door to the museum. Folks at home, you can maybe guess where this is. I'll give you a moment. It's MoMath. It's the Math Museum. This is a real thing in New York City. And here's LadyAda in front of Stephen Orlando's artwork. You can read about this on our website, but you can see how Stephen makes this. This is long exposure photography, but uses specifically Adafruit stuff. And
I love this photo. This is a great one.
And what was cool is the photographer, the artist, Stephen had a person there at the gallery with a phone, and they were broadcasting to him live. And we happened to walk by, and he was saying, "Find that person with pink hair," and we found each other. And so here's just some of the art from Stephen. It's really cool.
That's beautiful art.
This was my favorite one. This is
The
what I
violin,
learned. Yeah. So check that out. Okay, it's time for chip shortage. This week, Texas Instruments, we need some stuff that you have, and we need it, and we want to figure out a way to do it, because there's a lot of people that want this stuff, and we like Texas Instruments, and we like stuff, but we can't get it. So, LadyAda, what is this week's chip shortage?
Okay, so this week's chip shortage, I try to alternate chips, fabrication companies, because I want to give all of them, and I will say that they have been responsive, and hopefully we'll be able to get some chips in. So thank you to the previous highlights in chip shortage. We have a catchy tune because we want to catch them all. So this week's chip shortage is the INA 219, although I'm going to toss in also the INA 260, which we also can't get. Basically, a lot of the INA series is very challenging. We use this in our very popular INA 219 breakout. We just used the last of our chips to make some breakouts, so we have some stock now, but we are going to run out before the next chip.
And by the way, straight up, when you search for this online on the Google, what comes up, our product, images, some of our images, some of our code and stuff, and then DigiKey. So, this is in everyone's best interest to, get us some, we just need some chips.
And I have the order through DigiKey,
We
so
just need some chips.
if TI could allocate some, I've learned the thing is now that there are chips, but they're just not allocated.
How many of these would be ideal? Because
I
I'm going to
think
send an email.
they need a reel of about 3,000. We have 3,000 or 4,000 on order, so if we could just fulfill our order that we placed, I think 6 months ago, I would love that.
And these are used for education. We have.
Power monitoring, solar projects,
IoT.
all sorts of stuff.
We're not using them for bad stuff.
I'm not. There's absolutely no kittens being crushed to death by the INA 219.
So anyways,
or INA 260, or I think the INA 280 is the other one.
please, Mr. Texas. I think that's the CEO's name, Mr. Texas.
Mr. Texas? Yeah. Hold on.
So a reel of 3,000, is that what you want?
I think they come in reels of 3,000.
Okay. All right. So that's our plea.
Thank you.
That's our chip shortage.
Yes, INA 219, 260, and 280.
All right. So these little jingles have become popular. And so
they
folks
gotta be
want more.
catchy, 'cause I gotta get these chips.
So now we have one for Mailbag. So this is the debut of the Mailbag song.
Letters, we get letters, we get tweets and we get emails. Your comments via RSS, they are the best. Now it's the time for Mailbag.
All right. So that's the Mailbag song. Letters, we get emails, we get tweets, we get comments over RSS. They're so great. So we're going to do the letters. So this one came in. I like this one a lot because it is something we're going through right now, which is doing the best job possible with the supply chain constraints, specifically Raspberry Pis. So this one came in from Alan. Just wanted to say thank you for your noble attempts to keep the Raspberry Pi supply going. When someone says noble attempts, by the way, they mean like, oh, you're getting sliced and diced out there. I've been attempting to catch stock for weeks and weeks. I've always got to place the point to the order point, only to be met with out of stock. Can't process denial. Nothing to do with Adafruit. You've always been a massive source for all things IoT. You've never let me down, whether it was a technical questions, great ideas for great purposes. I managed to get one of the Pis that hit the stock this morning, and I'll now be able to complete my Home Assistant node for my workshop. Thank you, thank you, thank you. Have a fantastic weekend. I'll be joining mine deploying that critical second node.
Okay. Now's a good time to mention that we do have Raspberry Pis, and we do release them every week. There is a shortage. About half the people who are ordering Raspberry Pis are being naughty with the Raspberry Pis, and we're not going to really let people be naughty anymore. And so, people who are ordering Pis, I'm not going to be very specific about what we're doing to detect naughtiness. However, if you have a Raspberry Pi and you're ordering another Raspberry Pi, doesn't matter what model, within about a week or two, you may not end up getting your order. So please wait. Please don't just buy any Raspberry Pi you can if you don't need it. Like if you need a Raspberry Pi 4 2G, don't try to get a 4 and then a 2 and then an 8. Don't be like, I'm going to collect them all. This is not Pokemon. We really think that there's enough for everybody if people would not be naughty.
Yeah, the biggest issue, just to be straight up, is there's a small group of people that keep buying them from everywhere, and then they're immediately putting on eBay and they're selling them for $200 or $300. And that's not good. Please don't do that. If those folks didn't do that, there would really be enough for everyone right now. Like that's what we're seeing. So we've managed to stop thousands of attempts on this now, and we're getting better and better at it, and we will continue to do that. So please don't do it. And if you're thinking about doing it, think of something else. I don't know.
Yeah, and
okay.
I will tell people, do not try to I'm going to order every single day and I'm just going to collect. If you only need one, get one. If you need more than one, please wait before you place another order, because we can't tell the difference between people we will not tell the difference between people who are like, oh, I need 6 for my project, and people who are like, I need 6 because I'm reselling them.
And if you're active on eBay and you see one of the sellers, because they put our box in it, they're like, genuine Adafruit Raspberry Pi, message them and say, hey, this is really messing things up for other people. Please don't do that. If we have enough people that say that, maybe they will.
But we're not going to restrict it to prior orders.
So Pi Maroni's doing that. There's
Which
a
is
bunch,
fine.
Yeah,
Totally cool.
everyone's trying different things, and we're all learning from each other.
Yeah.
But one of the things that we know is there's more people who don't have a Raspberry Pi. There's more beginners out there, so we don't want to restrict it to people that ordered from Adafruit last year. We still want people to get Raspberry Pis. So we're just working on lots of different things, and our success rate of stopping people is pretty good, but it's a never-ending project. It's never over because there's very motivated people, because if they can get these and put them on eBay and they add $200 or $300 per Raspberry Pi, they get 10 Raspberry Pis over the course of a month. That's a bunch of money. And
if you didn't get your Raspberry Pi or your cancels ordered, wait a week and order again.
You can do that. Okay, some retro stuff. This one's a little different this week. Isaac posted up a very cool post. It's on our blog right now. We showed all the different ways, not all the different ways, but many of the ways, and you can post up the way you've been doing it, to scan in books and more. So we scanned in this cool book, how computers work, computers, their history and how they work. From 1969, there was like only a few computers. So this was a really neat book to test this out on. And so we looked at all the different apps that you can use, from physical scanners to phones to software that helps do this. Some is free, some is paid for. And we looked around, there wasn't a resource at all for this. And also there was a bunch of, the web is kind of littered with a lot of dead ends. And so there's traps, you download something and now it's like a virus or something, or malware, who knows. And so we tried to put together the best resource for all the different ways you can scan in, and then we showed how we scan that particular book. Okay, next up, some help wanted. This is from the jobs board, jobs.adafruit.com. You should go there now. This is 3 from the same company. They just posted it up. It's kind of cool. This week on the jobs board, let me just get this bigger here. Custom module for RP2040 CircuitPython software module, the UART module for the RP2040 CircuitPython software module, and ADC analog to digital control RP2040 CircuitPython software module. This is the perfect place to post this job because the makers out there could just do this.
Sounds like driver work, yeah.
It's a contract remote job. If you want to make a buck or two, you could probably do it. And you could probably just use our guides and do this project. Python hardware time. Okay, this week we're going to focus a lot on MicroPython, but first, a little bit of a note. There's this programming language index that comes out all the time, and it shows the usage of all the different languages, and Python kind of went up to the top. Probably because of machine learning and data sciences and all that, but also
and this is for embedded use.
Microcontrollers. It's for a little bit of everything.
Yeah.
So Python's up there. So sometimes folks are like, well, where do I know? Which language should I think about? And this is ones that are used the most, and probably will continue to be like this for a while. So if you learn Python, not only do you probably have a marketable skill, but you're also able to do things like hardware now. So consider it. I'm going to get into some of the MicroPython news soon. We have a roundup of what happened over at PyCon. A lot of hardware projects. We're still wrapping up some stuff from May the 4th be with you, May 4th.
Star Wars project, yeah.
Yeah, and then just a lot of interesting stuff. While the iPod is now retired, you can kind of make things like this is a password keeper. But you can still make interfaces if you like the look and feel of something like in the old school iPod. You can. And then congratulations to Solder Party. They released some new hardware. This runs CircuitPython. And then I just wanted to mention, with MicroPython, there's new cool stuff going on all the time. There's a RISC-V build that's going on. We celebrated MicroPython's birthday last week. Happy 9 years old. And this was one of the cool things that you can do with the code, the visualization. We did a chip shortage about the ST chips for last week, but I have some bad news though.
Uh-oh.
Here's the bad news. So we're like, hey, Adafruit's a sponsor, organizations can sponsor.
Did we sponsor them?
We sponsored, and we wanted to sponsor just to get it almost over to the edge. So we're doing like $500 or so a month, and we also have donated directly and we're also going to do other sponsorships with MicroPython. But I was like, hey, 84 of us are now sponsoring. Surely, because of 9 years,
If we get like 16 people to donate
we
a
just
couple
need a
bucks,
couple people. So
Get them to the goal.
so the bad news is nothing's changed in a week. No one else
No.
has sponsored. So you need to go to github.com/MicroPython. Don't buy stuff from Adafruit tonight. Just do that.
Yeah. Remember,
I am once again asking for your financial support.
that's Damien. No, it's not.
So the reason for this is if you're an open source maintainer, contributor, creator, and you have a goal and you don't hit it, you might decide not to do that again. Or other people might see that and they say, I'm not going to do it because I couldn't even get a small number of people together. So please, 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 please. I think we're the biggest sponsor right now, but maybe we can just get a bunch of small sponsors out there and just let's get to 100%. So github.com/MicroPython. If you work at a company and you're using MicroPython, and you probably are, I don't think we have competitors. I'll call them like whatever they are. Like there are other companies that are in our exact business who, they'll base their designs off our hardware, which we like. It's open source hardware. They also do a lot around MicroPython and CircuitPython. Please, please, please consider
Support them.
You have your repos on GitHub. You can sponsor as an organization now. Please, please, please.
Especially because there's this chip shortage, and so there are no Pi boards available right now because the ST chip isn't available.
So,
they're trying to get more, but it's harder for them to get income. Sponsor them.
I'll say this: even if you just do like $1 a month, just let's just get it more than 84 because it's a bit of a bummer that we did this push last week and we were the last one to do it. So, anyways. I got to use this graphic.
I don't mind. There's 84 people dancing on the the dance floor.
Yeah.
Don't you want to join us? We're having a good time.
Yeah, that's Python Hardware News this week.
That's some good guilting.
Yeah, all right. Open source hardware news, LadyAda. We have 2,671 guides.
Lots of guides today.
What's on the big board this week?
Okay, can you make it big? Because I can't read a little text.
Yeah.
Okay, first off, we've got the amazing MIDI laser harp. I have a video from Liz. I've always wanted to have a laser harp build on Adafruit, and having the inexpensive time of flight sensors with CircuitPython drivers has made this possible. The laser harp can do MIDI out. It actually generates the audio using the MIDI featherwing. Or, of course, it can plug into your computer and send USB MIDI messages very easily. It's a fun build. It's one of the easiest laser harp builds I've ever seen. A lot of them have to use sensors. And you have to calibrate them. Total pain in the ass. We fake it by using time-of-flight sensors. The lasers are for show, but they're a very cool show. So that's great. We've also got a big update to the RP2040 PIO with CircuitPython guide. Jepler has added in CircuitPython 7.3 the ability to do background tasks in PIO, which means that you can stream data continuously without having to wait for the PIO to return. Like it returns immediately and it can go in the background. So stuff like having servos or 7-segment displays or Charlie Plex matrices type stuff, that can all be done. He has a lot of demos that he wrote up and explaining all of them. So I think PIO is in a really good spot now. You can do quite advanced projects, including like background DMA NeoPixels, all with CircuitPython dynamic PIO. So you don't have to write any C code or compile anything in. You change the PIO, it immediately starts running.
Okay, we're going to play the harp video after this.
Of course. We've also got the Raspberry Pi stock alert alarm from JP. Of course, it doesn't use a Raspberry Pi because that would be cruel. Instead, it uses an ESP32S2 TFT board, which is great because it's a little TFT to show you the output and also driving the alarm. It's also a really good example of how to use a TIP 120 power transistor to drive loads like this alarm, which uses up to 12 volts. Melissa did a really quick demo with Runestone, which allows you to edit and write code on an external drive, where CircuitPython looks like an external drive. One of the really cool things about CircuitPython. And so you can actually edit and write code on Runestone, plug in your board, and she gives some tips on how to do that. Liz also has been writing some guides as she's getting spun up on Adafruitisms. She wrote up a guide on the DVI breakout board, and then JP jumped in and showed how you can customize the HDMI bouncing head demo with your own favorite graphics, not just the Raspberry Pi logo and Eben's head. Maybe you want different heads. Maybe you want different logos. And then NonePager did a fun project this week as Cutie Pie NeoPixel flexible neon signs without any cutting or splicing. We just have exactly 1 meter long strips with various cool colors, and then using the animations library to display cool stuff. By the way, Phil, did anyone sponsor Michael?
I've got breaking news.
Breaking news.
Breaking news, breaking news, breaking news. Guess what, everybody?
What?
We're up to 87.
Sweet.
So we were at 84, now we're at 87.
Thank you.
Yeah. This is gonna, we should give out mugs and like tote bags. This is like, it was like the
PBS,
the old public television.
You tell me, PBS is not that old. It's still happening.
No, the fundraisers and stuff like
Yeah.
that. They used to be like, and you get
NPR
a tote.
gives you a tote.
You get a tote bag.
You get a tote bag.
Yeah.
I love the people in the background that would be pretending like they're
Yeah,
answering the phone.
ring. I like the dystopian version that RoboCop had, where they were trying to save the city, and the mayor was like singing and like doing stuff. And
Yeah.
Anyways.
Or is that UHF?
No, I think it was both.
Oh, both.
Okay, sorry. So let's play some laser harp. Thank you
Okay.
everybody who's sponsored.
Keep sponsoring.
I want to say it was RoboCop 2, and there was a guy playing
It
the
sound-
fiddle,
it
and he was
sounds
doing a
RoboCop 2.
split, and he was playing like Born to Be Wild on a fiddle.
That sounds like a RoboCop 2-ism.
Yeah.
RoboCop 1 was a little more serious. I mean, it wasn't
Yeah.
serious, but it didn't have that kind of thing.
I'll pay $1 for that. Okay, let's do some factory footage. And it would be made in New York City factory footage. Unless you saw this cute little forklift
Oh, look at how cute that is.
in the Disney building. It's building it from the inside.
Oh, and it's up and down, up
Yeah.
and down.
All right, some 3D printing. All right, we got 2 videos. We're going to do these back to back. One is the light up neon-like stuff, And the other one is a 3D print of this cool pen holder, pencil holder made out of snakes.
Snakes.
Hey, what's up folks? In this project, we're making color-changing, neon-like signs with 3D printing and NeoPixel LEDs. These strips feature flexible silicone diffusion for a neon look with the individual addressable capabilities of NeoPixels. Powered by the Adafruit Cutie Pie RP2040, this powerful but small and low-cost board is perfect for these type of projects. We designed and 3D printed some signs that allow you to use the full meter-long strip of NeoPixels. It's a simple, easy press-fit installation, so there's no need for cutting or splicing. The 4 designs use a meter-long strip to make simple shapes designed to fit on the bed of our 3D printer. Pair it with CircuitPython for easy-to-program LED animations. With the LED animation library, you can string together several animations to make a sequence of custom colors and speeds. CircuitPython's ability to easily make changes without compiling or installing an IDE means you can get projects quickly up and glowing. The strip features pre-wired cables that we can use to connect it to the Cutie Pie. Cut the end off of the strip and solder the wires to the pins on the dev board. Then load up our example code. Be sure to check out the guide on the Adafruit Learning System for a full step-by-step tutorial on building this project. Now we can easily connect the NeoPixel strip to the Cutie Pie and power it off a 5-volt USB battery or power supply. The NeoPixel strip fits into the channel and stays in place thanks to the grip of the silicone. And that's it! We hope this inspires you to check out Cutie Pie and use CircuitPython for your next LED project. Thanks for watching, and be sure to subscribe for more projects from Adafruit.
And don't forget, you can learn how to make all this stuff and more on 3D Hangouts with Noah Pager every Wednesday, the longest running 3D printing show on planet Earth. LadyAda, a little reminder, traffic is code. You get the free stuff.
Choo choo.
You could two-factor your account while you're at it so you can get a pie when we have
Good
them in
idea.
stock.
Make an account.
Yeah.
Get all your addresses set up now. So when there's a pie, add
You
your
can do
cart, log out.
Yeah.
Log in, add to your cart, check out.
All right, sign on MPI time.
on MPI.
Ion MPI brought to you by DigiKey and Adafruit. This is when we take a look at something new over on DigiKey. LadyAda, what is it this week?
Okay, this week it's from NXP. And I want to get the part number correct. This is the P3S0200 GMX. This is an I3C bidirectional switch. And you might be like, hey, you just said, and it comes in this package, the XQFN10. You might be like, hey, you just made a mistake. When you said I3C, you meant I2C, right? Because what is I3C? Well, this is I on NPI, and we have an extra I. This is, we're going to talk about I3C because I thought it was kind of interesting, the differences between I3C and I2C. And there's an extra I. This is the next generation of what I call I squared C. I guess this is I cubed C. I don't know. We have to come up with a name. I have started to see more sensors and devices with I3C, sometimes called MIPI I3C interfaces. And so I took a little bit of a deep dive, and I thought I'd tell you all about it, and then you'll know why you need this I3C switch. So first up, this is what it is. It's actually, this is still very useful. Don't forget, this is also compatible with I squared C devices. You have your mic controller on the left. You can connect the A and B or SCL and SDA. And you also have a select and output enable. Output enable is is the whole thing active? And select lets you connect either to A1B1 or A2B2. So, we've got an 8-way switch for I squared C, but this is you're not changing some sub address, and you just when S is high, you connect to one of the targets. When S is low, you connect to the other. So it's an easy way to connect two devices of the same I2C address without having to do any funky muxing. So this is a useful switch just for like you have two devices of the same address, or maybe for some reason they conflict or whatever, you want to keep them separated. And of course you can turn off the output enabled to save power. This is what it looks like on the inside. It's, there's like this charge pump because you have to be able to control up to 5-volt logic levels. And the control logic support is in there as well. So it's pretty simple. It's not a very complicated design. And also, if you're familiar, it looks a lot like the I2C logic level shifting that we use all the time for converting between 3 and 5-volt logic level. So if you didn't know, which is fine, now you know. Today's a day you've learned that the I2C bus specification was written and designed by NXP Philips. Philips, which is owned by NXP now. They wrote the original I2C bus specification, which is written here. And I think this was published in like the 80s, and then 1.0 was released in 1992. It's been updated, and this is what the original I2C description was kind of intended to be. You'd have the SDA line and the SCL line. And look, you can connect your microcontroller driver, and then you've got some RAM, and you've got an ADC, and you've got an LCD, and a gate array. Look at us, we're having so much fun. Everything is just sharing these two pins. Isn't it wonderful and perfect? Well, that's not actually what ended up happening. So what we wanted was to have all these devices share two pins. But as I'm sure anyone out there who's actually implemented I2C devices, it's never quite that. There's D-readies, there's IRQs, there's select pins. There's like always more stuff because I2C is, a polling interface, and you need interrupts, or you need to have like data readies or selects, or there's other, things that you have to connect to, or address changes. And so, and then intermixing with SPI devices because you need higher speeds, and then like now you have a chip select for every line. So what I3C is intended to do is replace all of that with a high-speed, again, 2-pin interface. Well, really, what we intended is what we got. So, like, for real this time, right?
For real.
So, MIPI, which you may be familiar because they also published display and camera specifications and other specifications. They do publish the I3C spec. They do have this annoying-ass thing where you have to log in to download, although you can find it on like Scribd and stuff. And then like if you want the official version, if you're a member, I don't completely understand it. I think it's kind of silly. I think if you have a spec, just publish the spec. But this isn't about them. This is about this I3C switch. So just going to move along. You can get the full specification from the MIPI website. They also have a great FAQ. And this is basically, compare and contrast. So in the middle, I2C, and you see there's SDA and SCL, but then there's like interrupt pins. On the right, there is SPI, and they share clock, data in, data out, but then the chip select lines are separate, and also there's interrupt pins. And then the left, amazing, I3C. No chip select lines and no interrupt lines. Why? And we'll talk about that in a moment. So here's the first I3C spec that was published, and some of the things that they're going for. So some of the things that are interesting, there's a lot. There's first off, it's back compatible with I2C, which I think is really cool. There's standard data rates and high data rates. So you can basically get to SPI type speeds, 12.5 megabits per second, megahertz clock rate. There is again, backwards compatibility. There's hot join capability. There's in-band interrupt capabilities. There's low power and basically getting rid of like the passive pull-up capabilities. Trying to standardize on the command codes. And there's like some more advanced stuff like the queue support, which I'll be honest, I didn't quite read into that. There's also CRC that you can do. But basically you can put, you can use I2C with I2C and I3C devices, and then you can like pop into I3C mode by doing special addressing. You write to the address 7E to kind of tell I3C devices, hey, we're going to put you into I3C mode, and then you can go into this high speed support. So this, as you can see, it's meant to be back compatible. Hey, clock stretching is a total pain. Well, they took it out. You can no longer clock stretch an I3C. So that's the one thing that is not supported. And also, pull-up resistors are done differently. Instead of having these passive pull-ups, which draw current and slow down the bus because you have to charge the capacitance of the line and the gates, the SDA and SCL lines, you can have, they have these pull-ups built in, but they switch into active push-pull mode, and so that's how you can get those high speeds. Also, they no longer support 10-bit addresses because basically nothing ever supported the 10-bit addresses. I've never even seen it, and so they just said, hey, nobody used this, so we're tossing it out. But I really like that they got rid of clock stretching, but instead they added some things that will help with clock stretching. Oh, this is the address. You're wondering, like, how do you send I3C commands? They go to address OX7E because OX7E is not a valid, it's a reserved I2C address. In case you didn't know, anything I think above 7.8 is unavailable. Anything below 10 is unavailable. And then, of course, 00 is the all call. I do recommend in the text version of this INMPI, I'm going to link to a really good presentation from NXP about I3C, which goes into low-level details of this. One of the things I forgot to, can you go back, sorry, to here. I forgot there was one thing I wanted to mention. Because I had the detail in the text, but I couldn't find a good, I do have an image, but it's not described well. So you'll notice in the middle image, there's I2C, and there's the SDA and SCL lines, and there's the interrupts. And then you'll see on the left, there is no interrupts. So when they got rid of clock stretching, right, clock stretching is often used for, you want to read data from a sensor. So you say, I'm reading from this address, or you're writing like start a command, and then you want to know when it's time to read the data because it has to do a humidity sensor check or, take the fusion of some accelerometer data. Clock stretching is what a lot of sensors use to tell the controller, hey, hold on, I'm going to get that data for you, just like give me, a couple milliseconds to do so. But clock stretching just became a pain because, not all hardware supports it, and the timeout's variable, and it can hang the bus, and some devices don't like it. And so the right thing to do is to have an interrupt line, so you can write to the I2C peripheral and say, look, I'm going to, I'm asking you for humidity data, and then the interrupt pin toggles to tell you, okay, it's time for you to pull to read that sensor data. That way you're not polling constantly, using up a lot of power and computation time because you have to be awake to constantly poll when it's ready. And that's because I2C is, controller run only. Only data can be requested by the controller. The peripherals can't push data back. It's not asynchronous like UART. But what's neat about I3C is they have this thing called, this is the wrong slide. But this is a good presentation. So they use in-band signaling where this shows the high-speed stuff where it goes from push-pull into active open drain to push-pull mode, and that's how you get into higher speeds. But the other thing it can do is in-band signaling where the the controller can release the bus and say, hey, when the peripheral is ready, it can signal on the bus that it's ready to be read, and then you don't need those interrupt lines anymore. And I think that's quite interesting because one of the things that drives me a little nuts about I2C is like you've got this dream of only using 2 pins, but then before you know it, you need like 2 other pins just to manage interrupts and data ready and wakes and all that good stuff. All that is going to be built into I3C. You're going to start seeing, I'm starting to see sensors with I3C, especially ST and NXP devices. I haven't yet seen any low-cost microcontrollers with I3C, but I think you're going to see it soon. And of course, you could implement this in PIO. So if you're, given that I3C is back compatible with I2C, a chip like this switch, getting back to the INMPI, the P3S0200, is really nice because if you do use this switch in your design, it can run at the low frequencies, 100, 400 kilohertz of I2C, and then when we all upgrade to I3C over the next decade or so, you won't have to respec the design. It'll be ready to use I3C as your sensors, like I've seen ST sensors, their magnetometer the old version is I2C, and then the next version is I2C or I3C. You'll be able to upgrade all your devices and you won't have to switch out the switch part because it'll all be ready for that high speed and these funky capabilities of I3C.
It's available on DigiGate.
So that was your lesson. Now you know, because I was like, there's a switch, it's handy, but why do you want the switch? Now you know
And
you're
there's like
ready.
almost 5,000 in stock.
Ready for the future. Well, I got 5 of them. I mean,
Okay.
this just came into stock like yesterday, so
Okay.
I picked some up.
Do you want to show anything on the overhead?
No, there wasn't any
Okay.
videos. I will say the only thing is check out when I post the text. We post the text tomorrow, the next day. Check out the presentation of NXP because it's very nice, high level and trace level details between I2C and I3C, and it'll be very helpful as you implement I3C, so you know what are the constraints.
All right. Good explanation, LadyAda.
I know.
And that's this week's Eye on MPI. All right, we're going to roll right into new products, but first, don't forget the code is traffic. LadyAda, are you ready to sing your song?
I am ready.
Yeah?
New.
All right, first up, don't forget, these are back in stock, Circuit Playground Expresses. They are going fast.
We got a shipment.
So, next up,
We have a WFL Wi-Fi/Bluetooth antenna. It's a 2.4 gigahertz antenna with a WFL connector, perfect for. We recently put in the Feather V2 with a WFL connector. So this is a nice long, I think it's like 20 centimeter long cable. It's got a little PCB trace antenna on the end. Here it is. It's got like a tuned antenna. It's, I think, 2 dBi gain. Nice long wire with a little coax here. So this is a WFL. I want to just mention that this is a UFL, and this is a hold on. This is so small that I got to like twist it. So on the right is a UFL, and on the left is a WFL, and you can see the WFL is smaller. The UFL looks like it'll fit, but you're like, uh-oh, it's significantly tinier. So this is also called an MHF3 or an IPEX3. This is definitely going to fit on the little connector that's on these ESP32, whereas the UFL will not, so just don't mix them up. If you have UFL, get this product, 2308. If you have WFL or MHF3, get the one here.
okay, next up.
Next up, we have a iSpy cable that's really short. We're going to be doing more iSpy stuff. We're waiting for some connectors and displays to come in, but we've already got it in the longer cables. Maybe you want a shorter cable. We have that now.
Next up.
Speaking of cable length, we also have long stem QT cables. People have been asking. They want long, and they want them with cable covers so that they are not kind of splayed
A
around.
couple different times.
So we've got these cables. You can see that they are stem QT. They work wonderfully. They are 300 and 400 millimeters. You'll see we interleaved the data between the ground and power. Yeah, if you look here, you see how there's like a little bit of a twist there. We do that on purpose because it seems to reduce crosstalk a little bit. I think it's worth a shot. Why not? So you get ground, data, power, clock, and so you have 2 DC signals between AC because, of course, I2C is not differential. You can't just twist the wires. If your signals aren't differential, don't twist them. It doesn't do anything. In fact, it can make things worse. So less crosstalk and long cables, great for your stem QT, and also they're nice and covered almost completely. And if these are good, we'll get even longer cables. Maybe we'll get a full meter. Nuts. Next up, this one, skip this. This is the...
Skip it?
Yeah, sorry, that's the wrong... No, just that one image.
Oh, okay.
Sorry. This is a USB to magnetic 4-pin cable connector. So we have these really cool cable connectors, which were in the previous video, but it's a little confusing because it's like that's not the
Oh,
product.
that's why I got it. We don't want to confuse anyone. So pretend you didn't see this, but this is how these things work.
Yeah.
Okay.
So there's magnets. There's 4 pogo pins and then north and south magnets.
Do a real.
Yeah, we can just show the real thing. So, before we just showed this and another pin connector cable. This one has a USB on the end, so you have power, ground, data plus, data minus, and these you can't I'm trying to plug it in and it's like not plugging in because it's not the right way. But when I flip it over, it connects very nicely, and so you can get a waterproof, weatherproof connector. If you seal this on your contacts, you don't have an exposed port. And then when it's time to upload code or debug or connect to USB, you just plug this on. So this cable is only the cable. It doesn't come with the matching contact. We'll try to get it with a single contact in the future, but for now, you'll have to pick up the other kit set that has the 2 sides, and this connects to the flat side.
Okay. And
Still
then
very handy.
next up.
Next up, this was because I was putting together a computer and I kept losing little screws and stuff, and so I was like, I want to have a little kit in the store that has all of the different chassis fan, motherboard, M.2, O-ring, hard drive, SSD, floppy disk, optical disk, whatever connectors that you could possibly want. So you get like 10 to 20 of each.
Yeah.
Pardon me. Oh, I got the sneezies. And you also get a screwdriver and some silicone heat paste. So if you're attaching a heat sink, that's very handy as well, because that stuff dries out if you don't have the fresh stuff. But it has a little bit of everything, because I think if you've ever put together a computer, it's like you lose these screws or you forget which one, and some of them are like unusual. Some of them are like M2s or M3s, but some of them are like these weird sheet metal screws that are like, if you don't have it, you're never going to find it at the hardware store. So I like having a combo kit. It also has those large thumb screws that are always used for the enclosures.
Okay, and the star of the show tonight, besides you, LadyAda, our community, our customers, our staff, and everyone who makes this happen, is
This little traffic light.
The cutest, tiniest traffic light ever.
Yes, so this traffic light,
Beep, beep.
it's used for model makers, but I just thought, anything with LEDs in it is always so great. So it's basically a common anode setup with 3 LEDs, red, yellow, green. As you expect, I think there's a resistor inside, so you can just power it directly from 3 to 5 volts, but here I've just got it connected up to 3 volts. Maybe I'll zoom in to get nice and close, and then auto focus. Hold on. This is okay. Bam. So I've got the yellow, and then over here I've just got wires connected. So it's common anode, so you'll want to keep the red wire connected, and then you can touch the yellow, red, or green wires to ground to power them. So I'm just touching them to the alligator clip. Turn on the red, or turn on the yellow, or turn on the green. 1 second. I'm just going to disconnect this. So, or you can turn on the green. So, red, yellow, green. What would it be good for? I don't know, but it's like small and tiny, maybe jewelry or wearables or a little. We have tower lights, but what if they're too big? What if you want like a very tiny tower light?
Well, one of the projects is like, what if you have a conference badge and you want to have a indicator, red, I'm not going to really talk right now. Yellow, maybe, and green, yeah, talk to me all you want. So we thought that would be kind of a fun little.
Yeah, it's actually got that molded plastic cover, so it actually looks like a traffic light.
Yeah.
And then it's got a metal pole, which again, it was intended for model making, or maybe you're making we went and saw that model railroad or model train set, or you're making a dollhouse, and you want to have safe crossing for your dolls.
That's right.
This traffic light will do it.
And that's new products. Okay, cool. Don't forget to code traffic. We're going to do a top secret, but while we do that, please put your questions in Discord, adafruit.it/Discord. We're going to start to answer them. Let's do some top secret while you load them up over there. Okay, so this week, LadyAda, you were making sure all of our Circuit Python stuff works with Azure, because we're going to be doing a bunch of Azure projects.
That's right.
So take it away past us.
LadyAda, what is this?
Hey, this is a Feather TFT ESP32, and as you can see here, sending data to Azure. This is running an Azure IoT demo where I'm sending data from this barometric pressure, temperature, and humidity sensor, as well as the battery level, to Azure. So I'm kind of experimenting. I've never made an Azure account, but this is a really popular IoT service. And I'm probably going to do some guides on this. And here's an example of some of the telemetry data I'm sending. And you can see like all the data. Actually, the battery died this morning because I ran it all night. So you can see the battery charging and it's connected. It's really powerful. I mean, you can do a lot. You can create models and displays and gauges. So I'm going to do that next. But for right now, I'm just experimenting with, creating a model. And you can see, how do you create a model for a device and then connecting it to the device. So click instantiating a new version of this sensor model.
And that's top secret. Okay, we're going to answer some questions. Just some breaking news, though. MicroPython is now 96% towards their goal. They have 92 people sponsoring. When we started this, it was at 83. Well, 84.
It's okay, but
that's
this is
great.
better.
We're doing this.
Great.
This is what a community does.
Let's get
Thank you,
more.
everybody. That's very much appreciated.
Yes.
So let's do the questions. You ready?
Yeah.
And then we'll get out of here.
We don't have a question tune yet.
We will. Just straight up, over the last couple of years with everything being really tough, it was so the creative process and what you end up doing sometimes, at least for me, so the music stopped playing in my head. So there's a lot of stuff that we do at Adafruit where it was like I had to focus on so many specific things and working with our team who does music and everything. It was just really hard. And like there wasn't the tunes, there wasn't the music, there wasn't the lyrics, but it came back. And not because COVID's gone, it's just like you kind of get used to anything, which is not good all the time because you don't want to get used to bad things, but you also want to adapt, and that's what we did. And then the music started to come back. So anyways.
That's the new song we have this week for the mailbag.
Yeah, that's
I
one
like
of
to
them.
imagine Packet singing
Okay.
that song.
You ready?
Yeah.
Question. I'm going to go back in time here. Okay, question. The Arduino collector version of Uno is very small. What size is the female pin header blocks trying to find jumpers to wire to fit them?
I think those are 2mm, and we have 2mm jumper cables that go to 0.1 inch, but that's why I think it's, or maybe they're even smaller, 0.5, but I think they're 2mm.
Okay. Arduino preferred, but Raspberry Pi is also an option. What would you recommend for an offline voice recognition for a dozen keywords and have high accuracy? Second part of the question, with limited Pi, thoughts on ESP XX with built-in I2C?
ESP will never be able to do as good as a Linux computer. You really need to have very high computation. So I would think, I wouldn't even really mess around with an ESP because if you don't have 95 or better percent accuracy, it's going to be miserable to use.
So any suggestions for an offline?
Yeah, I would
voice
just use a Raspberry Pi or a similar Linux, single board computer. And there's voice recognition. I don't remember the name of them, but if you Google around, there are offline ones. They're not, you need to train them, but you're going to do a much better job. Of course, online is the best. Nothing's going to beat like Amazon Poly.
Okay. Anyone plugged in NeoPixels into a JRainbow header on an MSI motherboard with success from manual? The JRainbow connectors allow you to connect the WS2812B individually addressable as RGB LED strips, 5 volt.
I haven't done it, but I know that there's NeoPixel support on motherboards and I've seen it, and I think it's hilarious.
Okay. What is the maximum practical length of cable connecting I2C peripherals?
I think for 100 megahertz, you could probably do like a foot, but it really, really, really depends on the peripheral, the driver, and your pull-up resistors.
Chris is 50 feet with the Terminator.
If you have a Terminator, yes, you can go 100 feet,
Okay.
or an active Terminator.
Is it safe to have NeoPixel strips as components that are regularly hot swapped to a project, attaching them using magnetic connectors you have in the store? Any risk of damaging the board pins?
I don't know if you would damage the board pins, but I think you could damage the NeoPixels if you don't have ground come connected first. I wouldn't recommend it. I wouldn't really hot swap a NeoPixels. I wouldn't really hot swap almost anything.
Okay. I want to make a little project that can send data back and forth with a phone via NFC, being powered solely by NFC. Are there any modules that will help with that, or would I have to make a custom circuit myself?
We have the little NFC EEPROM that is designed to send data back and forth. However, I don't know if the ST library for it is any good. It's harder than you think. I would really just use Bluetooth.
Had a question. Does Adafruit IO work with Bluetooth or just Wi-Fi? Well,
You can use our app, and it can transfer one feed over Bluetooth.
the answer is yes,
but not very well. And again, it's only one feed. But it does work when you use your phone using our app, Bluetooth Connect, as the bridge.
You can, and that constraint is actually kind of nice because if you're doing something over Bluetooth, you're probably only doing like one thing anyways.
Yeah.
Okay. I had a question. In the factory footage, we often see a machine that looks like a solder fountain. Is that some kind of wave solder system? What's it called?
It's a selective solder, which is basically a wave solder machine, but with one point. Wave solders would be much bigger. We don't use it enough to justify having a wave solder machine.
Okay, no question today. Just shout out to Adafruit product 1400, the push button power switch breakout. Saved my butt with the project today. Simple, effect, and a great way to mount a button to a handheld case. Thank
Yay.
you. All right. Question: how easy is the port? How easy would it be to port the NRF 52811B for Adafruit DAP? I got what I think would work, but I'm worried if some of the commands might be out of range. I'm struggling to see programming difference over SWD in the Nordic docs.
I've never used the 52811. I know we support the 52840 for sure, and the 51 whatever it is. I don't remember the part number. Those are the only two I've used. I don't even know if we've ported the 832. If it programs, but really we don't even own that chip, so you're on your own.
Okay, and let me just do a sweep at the other places. And that's it.
Okay.
That's questions. Thank you, everybody. Let me show the question logo.
Okay.
All right. Thanks, everybody. That is the show tonight. The code is traffic. I want to say special thanks to Kara, who's behind the scenes running things in
Thanks, Kara.
Slack, and all of the moderators and everyone in Discord. Special thanks to the entire Adafruit team, who not only gets all this stuff done, but it's a treat and a joy and a pleasure to look forward to doing something every day with a cool group of people that's looking out for one another. We need more of that in the world. And I know this community also are the type of folks that do that too. Thank you for supporting MicroPython. I know we asked for that. And I'll send a note to Damien. 10 people sponsored. They're going to probably get closer to their goal.
Thank you.
And this is just a live show, just us together doing this. And we'll continue to get the word out. But, thank you, everyone.
Pressure your family and friends.
Well, if you buy a board from another company that does anything with Python on hardware like MicroPython, and you don't see them in the sponsor list, encourage them, because now organizations can sponsor, and that is the mechanism in which MicroPython is asking for help during these times, especially because they can't get chips. So if we all just chip in a little bit, we can keep all these open source projects going. And I think it's not the money, it's the thought that counts with this, because open source takes a lot of time, it's a lot of passion. So we very much appreciate the folks that did that today. That's our show. We'll see everybody next week. Lots of shows ahead. This has been an Adafruit production.
Thanks, everybody.
Here is your moment of Zener. Good night, everybody.
Bye.